Questions 21 through 25 on the 2002 grade 12 AMC 12B. For all positive integers n less than 2002, let n equal 11 if n is divisible by 13 and 14, 13 if n is divisible by 14 and 11, and 14 if n is divisible by 11 and 13, 0 otherwise. Calculate the sum from n equals 1 to 2001 of an. So they want you to figure out the sum of n from 1 to 2001 of an. Correct? So this basically means a1 plus a2 plus a3 and onwards, a4, a5, and you get the point. All the way up till ... A2001, right? And for each of these, we have a definition of what that numerical value will be. So for example, A1, the 1 is what we're looking at, that right there. Since n is 1 in that case, is it divisible by any of these? Well, no, not even close, right? So it's 0. So A1 will have a value of 0. Similarly, A2, we're looking at n equals 2 now. Is n divisible by any of these? Again, not even close. So 0. And then similarly, you get the point. So how do we get numerical values? N has to be, let's look at just the first condition, make it simple for us. And I think I'm going to need some space, so I'll just erase some of these, and that shall give me enough information, enough space. All right, let's just look at that first condition. N is divisible by 13 and 14. 13 and 14. Remember, that's very important. Otherwise, this question, you won't be able to get it. It's not 13 or 14. It's 13 and 14. So if a number is divisible by 13 and 14, it must be divisible by 13 times 14, which is 182. All right? So any number that's divisible by 182 is meeting that criteria. So let's figure out, what are numbers divisible by 182? Well, we've got 182. 182 times 2, which is 364, 546, which is 182 times 3, 728. So I hope you get the hang of this. 910, 1092, 1274. These are all just multiples of 182, 1456, 1638, and 1820. And if I go any higher than that, I will have gone past 2001. The n has to be less than 2002. So these are values of n, okay? So basically what that means is that A 182, so in this list, for example, if I were to write it all out, A 182, like that, because 182 is divisible by 13 and 14, the value of A182 will be 11. All right, so I hope that makes sense. And very similarly, A to the 364. 364 is basically our value of n. 364 is divisible by 13 and 14, and therefore the value of A364 is 11. See what I'm saying? So that means all of these A, and so on, all of these terms have a value of 11. So that is how you do this question. So therefore, all of these guys, you have to add up. And how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 11, which is 110. All right, so we got all of these guys here. So this is done. All of those terms add up to 111. So we have to eventually calculate the sum of everything, right? So we got part of the sum. So let's keep going. I'll move this over here. I don't want to lose all this information. Now let's turn our attention to the next criteria, which is that if n is divisible by 14 and 11, the number an will become 13. Okay, so if a number is divisible by 14 and 11, it must be divisible by 14 times 11. And 14 times 11 is 154. All right, so all the multiples of 154 will satisfy that criteria. So we got 308. Just keep adding 154 to itself. 154 plus 154 plus 154, and so on. 616, 770. And you can easily do this on a calculator, but I think on AMC you're not allowed to use a calculator, which unfortunately for guys like me isn't so great. But I guess they have their own philosophy, because on the Canadian exams you are allowed to use a calculator. So who knows, right? What philosophies each organization has. All right, so those are the multiples of n those are the multiples of 154. So for each of these, it becomes a term, right? A154, A308, and so on. And what is the numerical value of each of these? I hope by this point you know the answer to that. It is 13. So A154, that term, is 13. And so on, all the way down. All these guys are 13s. All right? So what is the total? How many of these do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 13 is the sum, and that's 156. So we've got another sum. And now we get to the last one, so this one is all done now. Now we get to the last one, which is n is divisible by 11 and 13. So if a number is divisible by 11 and 13, it must be divisible by 11 times 13, which is 143. All right, move that over. So all the multiples of 143, 286, 429, 572, 715, 858, 1001, 1144, 1287, 1430, 1573, 1716, and finally 8159. I can't go any higher because then I'll go past 2001. I'll get to 2002, I think. All of these are terms, right? A. And what is the numerical value of all of these? I think I'm going to have to show that question stem again. You might have forgotten. 14. So all of those are equal to 14. 14 and so on, all the way down. So how many do we have of the 14s? We've got 13 of them. So 13 times 14 is the sum, which is 182. And then any other a we don't have to worry about because it has a value of 0. So if you add up all the a's from A1 to A2001, these ones that I just drew out are the only ones that have a numerical value. All the other ones have a value of 0. So the sum of all of them is going to be 110 plus 156 plus 182. So the sum of, what do we have here? N equals 1 to 2001 of a to the n is equal to 110 plus 156 plus 182, and that is equal to 448. So the answer to this question is A. For all integers n greater than 1, define an equals 1 over the log 2002 to the base n. Let b equal a2 plus a3 plus a4 plus a5, and c is equal to a10 plus a11 plus a12 plus a13 plus a14. Then b minus c equals. So b minus c is what we're interested in. So b is a2 plus a3 plus a4 plus a5, and c is, so we're subtracting, so it'll be minus a10 minus a11 minus a12 minus a13, and finally minus a14. And then each of these is defined in a certain way. They've given you a definition here that a to the n is the log of 2002 to the base n, and it's reciprocal. So we'll write that in there, b minus c. A to the 2 would be 1 over log of 2002 to the base 2, like that. Exactly like the way they gave us, not changing anything. And very similarly, a3 is 1 over 2002 log to the base 3. a4, 1 over log 2002 to the base 4. a5 is 1 over log 2002 to the base 5, and so on. And then you're subtracting 1 over log 2002 to the base 10. And then very similarly, it would be 2002 to the base 11 minus 1 over log 2002 to the base 12, 1 over log 2002 to the base 13, and finally 1 over log 2002 to the base 14. All right, so that is basically our equation. Now there's a very important rule that is sort of the heart of this question. That is, if you have the log of b to the base a, it is the same as 1 over the log of a to the base b. So that will allow us to essentially flip all of these, get their reciprocals. So this first one, 1 over log 2002 to the base 2, becomes log of 2 to the base 2002, right? Exactly using that formula, or that rule, I should say. And similarly, all of these flip as follows, like this. 2002 log of 4 to the 2002 plus the log of 5 to the base 2002. All right? And then you're subtracting a whole bunch of them, but we can apply the same rule. They all flip as follows. They become log of 10 to the base 2002, and then I put them in brackets, so the minus sign is out there, so don't get confused. I'm not making a mistake. I'm being careful here. Log of 11 to the base 2002 plus the log of 12 to 2002 plus the log of 13 to the base 2002 plus the log of 14 to the base 2002, like that. All right, so we're getting somewhere here. Now at this point, I hope you know that if you're adding logs like that and the bases are all the same, that basically means that you multiply. So it would be 2 times 3 times 4 times 5. That's another property. Okay? Like that. And similarly, it would be the exact same for the logs in the brackets. The base is all the same, so you can multiply the numbers. So it would be 10 times 11 times 12 times 13 times 14, like that. Okay, so this essentially becomes log. This whole thing is 120. So the log of 120 to the base 2002 minus the log, this whole thing, this big number is 240 to the base 2002. Now, I hope you know that when you subtract and the bases are the same, you divide. So it would become log 120 over 240 to the base 2002, like that. Okay? So this number here is 1 over 2002. That's what it reduces to. And 1 over 2002 is written basically as 2002 to the exponent negative 1. And I'm sure you know that. So let's bring this up here. So we know we can bring the negative 1 in front. So we have log of 2002 to the base 2002. And therefore you have negative 1 times this. Do you know what this equals? It equals 1. And therefore all you're left with is just negative 1. That is the answer. So this whole big long thing is negative 1, and therefore 22, the answer is B. In triangle ABC, we have AB equal 1 and AC equals 2. Side BC and the median from A to BC have the same length. What is BC? So let's draw our triangle. So we've got something that looks like this. And let's label this now. We've got A, B, C. And they give us a special rule here. Side BC and the median from A to BC. So from A to BC, we draw a line, and that's the median. What that means is it cuts BC in half. So it's going to fall approximately there. And I'll just label that D. So it cuts BC in half. So that means that if this is X, that's going to be X, the length. The length of BD is going to be the same as DC. And they're saying that that line, side BC, and the median from A to BC have the same length. So side BC, which is 2x, is the same length as this median, AD. So AD is also 2x. Not exactly drawn to scale, but I hope you get the point. And then AB, they gave us as 1, and AC, they gave us as 2, and they want you to find BC. So they want you to find the numerical value of that line BC. All right. So this will involve something known as the law of cosines. And if you are indeed in grade 12, you will have learned this by now. And I'm going to apply the law of cosines to this triangle twice. And I'm going to use this angle right here. And I'll call that theta, that angle. So first I'm going to apply it on triangle ABC. So here we go. We've got 1 squared is equal to 2 squared, this guy, and then 2x squared minus 2 times 2 times 2x. Move this over a little bit. Cos theta. All right? That is the law of cosines, basically. Now let's simplify. We get 1 is equal to 4 plus 4x squared minus 8x cos theta, like that. And then 8x cos theta is equal to 4x squared plus 3. And therefore cos theta is equal to 4x squared plus 3 divided by 8x. So that's about as far as we can go with that triangle. Now we apply the law of cosines again, but this time we use a different triangle. We use triangle ADC. And in that triangle, we have 2x squared, that side, is equal to 2 squared, that side, plus x squared, like that, minus 2 times x cos theta. Okay? And now we can simplify. 4x squared is equal to 4 plus x squared minus 4x cos theta. Put the cos theta on one side. 4x cos theta is equal to 4 minus 3x squared, and therefore cos theta is equal to 4 minus 3x squared over 4x, like that. So we have two values for cos theta, and therefore we can now set them equal to each other. So that means 4 minus 3x squared over 4x is equal to 4x squared plus 3 over 8x, like that. And let's see, before we cross multiply, we can get rid of the 4x's, right? If we got 4x here, we got 8x here, so this will just become 4 minus 3x squared, and this will become 4x squared plus 3 over 2, like that. And then we keep simplifying, and so we get cross multiply. 8 minus 6x squared is equal to 4x squared plus 3. Bring the 6x over, you get 10x squared. Bring the 3 over, you get 5. X squared is 5 over 10. And therefore x is equal to 1/2 the square root of that. Square root of a half. So let's see, square root of a half, is that one of the answers? No, it's not. All right, maybe they're rationalizing the denominator. So this is 1 over the square root of 2. Multiply top and bottom by root 2, and you get root 2 over 2 is x. Okay. And we wanted, what is BC, right? And BC, the length of BC is x plus x. So the length of BC is 2x. So BC is 2x, which is 2 times root 2 over 2, which is root 2. So root 2 is the answer to the question, and that would mean 23 is C. A convex quadrilateral ABCD with area 2002 contains a point P in its interior such that PA is 24, PB is 32, PC is 28, and PD is 45. Find the perimeter of ABCD. So let's draw a quadrilateral. And we don't know where point P is, so I'll just draw it somewhere in the interior like that. Right there, that red dot. I'll call that P. And then they're giving us some distances. So they're saying we have A, B, C, D, like that. And then the distances they're giving us, AP or PA, same thing, from there to there, is 24. And then PC is from here to here. And then PB is from here to here. And finally, PD is from here to there. Okay, so something like that. So therefore, we will label these. PA is 24. PB is 32. PC is 28. And PD is 45. All right, find the perimeter of ABCD. Okay, so in such a quadrilateral, we have a very important relationship. The area of the quadrilateral ABCD is going to be less than or equal to 1/2 of AC times BD. So what's AC? AC basically is the diagonal, like that. That's AC. And BD is the diagonal, like that. Okay? So if you were to take those diagonals, the numerical value, and multiply them and multiply it by half, they would be either equal to or greater than the area. Okay? That is a condition of such a quadrilateral, convex quadrilateral. So that basically means that the area of ABCD is less than this, almost always, but it can be equal, the other part of the condition, as well, right? Less than or equal to. And if it is equal, if ABCD, the area, I'll put area in there, if it is equal to 1/2 times AC times BD, that means that the two diagonals, AC and BD, are perpendicular to each other if the area is equal. So what we have to do now is we have to look at the numbers they give us and compare. So what we need to do is compare the area to the diagonals. So basically what we're doing is we're using this formula right here, this one right here. So we've got area ABCD is less than or equal to 1/2 AC times BD, like that. Okay? They tell us that the area of ABCD is 2002. They tell us that in the question. So therefore, this is 2002. Okay? Now, let's look at this part right here. 1/2 AC times BD. Well, we don't know what is AC. We don't know what is BD. But we do know that AC, for example, is a straight line from A to C, right? So therefore, AC must be less than or equal to AP plus PC. Correct? I hope you're convinced of that. AC has got to be less than or equal to that. It could be equal, but it definitely can also be less than, because AC is the shortest distance. And in a very similar way, the diagonal BD is going to be less than or equal to BP plus PD. So these values we have in our question, so we can plug them in. AP is 24, PC is 28, BP is 32, and PD is 45. So this gives us basically 24 plus 28, 52, and that is 77. And if you do the math, this becomes 2002. Well, 2002 on this side, 2002 on that side. So this means that basically the area of ABCD is equal to 1/2 AC times BD. We got the exact same value. So if it's equal, that means that AC is perpendicular to BD. That's what that means. AC is perpendicular to BD. So this diagram basically is as follows. Here's AC, here's BD, and because they are perpendicular to each other there, it means that these are right angles right there. May not look that way, and sorry it's not drawn to scale, but that's basically the condition. So now we are all set. We've got these values, 24, 28, 32, and 45, right? Because this is P right there. That's P. And since these are all right angles, we can use the Pythagorean theorem to solve for the sides of the quadrilateral. So if you do that, this becomes 40. This becomes 4 root 13, 113. This becomes 53. And this becomes 51. So for example, how did I get 40? I did 24 squared plus 32 squared is equal to AB squared. And then I solved. And similarly, the other side. So the perimeter is what they're asking for, right? Perimeter of ABCD. So the perimeter would be 40 plus 51 plus 53 plus 4 root 113. And that is 144 plus 4 root 113. And if you factor out a 4, you get 36 plus root 113. 36 plus root 36 plus root 113 all times 4, and that means 24 is E. Let f at x equals x squared plus 6x plus 1, and let R denote the set of the points x, y in the coordinate plane such that fx plus f at y is less than 0, and f at x minus f at y is less than 0. The area of R is closest to. So let's work with these two. We have f at x plus f at y is less than or equal to 0. So f at x is x squared plus 6x plus 1 according to the question, and therefore right here, and therefore f at y would be y squared plus 6y plus 1, and this is all less than or equal to 0. So this looks like, it looks like probably a circle. So x squared plus 6x, if you were to take half of that and square it, if you complete the square, you get 9. And very similarly, y squared plus 6y, if you complete the square, you get 9. And that's 18, but we only have 2, so we have to minus 16. So this becomes x plus 3 squared plus y plus 3 squared is less than or equal to 16. Okay? So that is a circle. This is the equation of a circle, basically. Now let's deal with this guy right here. So we have f at x minus f at y is less than or equal to 0. So that means x squared plus 6x plus 1 minus y squared minus 6y minus 1 is less than or equal to 0. And let's see, this becomes x squared minus y squared plus 6x minus 6y, because the 1's cancel, is less than 0. And I believe the factoring will help us, x minus y, x plus y. Factor out a 6, and this gives x minus y like that. Factor the x minus y, and you'll get x plus y plus 6, like that. And I think that is about as far as we can go there. So now we have to plot these on a graph. So let's make a graph. So we've got like that, x and y. And the first one is basically a circle, and it has a center of minus 3, and it has a radius of 4. So we'll draw that in this graph. So here is the approximate look of this circle. It has a center at minus 3, and a radius of 4, approximately like that. And now we have to concentrate on this right here. X minus y times x plus y plus 6 is less than or equal to 0. So this is true in two possible ways. The first way is if x minus y is less than or equal to 0, and the other guy is greater, like that. Okay, so that means that x is less than or equal to y, and x plus y plus 6 greater than 0. We can isolate for one variable here. Let's isolate for y. Y is greater than minus x minus 6. Okay, so these are obviously lines, so we have to plot them. The first one is the line x equals y, right? X equals y is just basically a line that goes, like that. That's the first one, x equals y. Okay, the next one is a line y is equal to minus x minus 6. So y equals minus x minus 6, so I'll plot that one. So when I plot this line here, this guy, it's going to be something like this, approximately. Something like that. So now we have to figure out what are the regions in this diagram that we are interested in. Because if you read the question, R denotes the set of points in the coordinate for which these are all true. So the area of R is closest to. So we have to figure out what is that region. The first equation led us to this, which is the circle. So that whole region right there, inside that, because it's not equal to, it's not just equal to, it's less than. So all the points inside that circle, okay, are part of R, the range, or the basically the set of points that we are trying to identify. So that takes care of the first one. Now the second one, which is right here, gave us another set of points. It gave us case 1, and then it gave us case 2, which is as follows. Case 2 is if x minus y is greater than or equal to 0, and x plus y plus 6 is less than or equal to 0. So that means x is greater than y, and y is less than or equal to minus x minus 6. Okay? So the first scenario, this guy right here, if you were to combine these two, where on the graph would that be? Case 1. X is less than y, and y is greater than minus x minus 6. And I'll label that line y is equal to minus x minus 6. That is this region right here. This region right here. In that region, x is less than or equal to y, and y is greater than or equal to minus x minus 6. Now case 2, x is greater than or equal to y, and y is less than minus x minus 6. Where is it on this diagram? It's this region right here, that region. So the area of those regions that I just shaded in orange is what we have to figure out. So how do we do that? I hope you'd notice one thing here. Y is equal to x. What is the slope of this line? Well, it's like 1x, right? And the lines are always written in the form y is equal to mx plus b, where m is the slope. So the slope of this line right here is 1, because m in this case is 1. What about this line here? What is the slope? It's like y is equal to minus 1 x minus 6, correct? So the slope of this line is negative 1. So that means you have two lines. One has a slope of 1, the other has a slope of negative 1. Therefore, those two lines are perpendicular. And if they are perpendicular, it means that this is a right angle. Okay? So that allows us to figure out the area of those shaded regions. How? Area of a circle, pi r squared, you know that. If that is a right angle, that's 90 degrees. So it's basically a quarter of the circle, because the full all the way around is 360. 90 degrees divided by 360 is a quarter. And we've got two of those, right? We've got two of those regions. And this diagram, sorry it's not drawn perfectly to scale, but you get it by now. So that takes care of the first region. And then the second region, would be the exact same formula. We have a 90-degree angle over 360, and then pi r squared. So here we go. 90 over 360 is 1/4. Pi r. What is r? What is the radius of the circle? It was 4. So 4 squared, again, 1/4 pi 4 squared. So this gives us 16 pi over 4 plus 16 pi over 4. And that's 4 pi plus 4 pi, which is 8 pi. So 8 pi is the answer. The area of r is closest to, okay, they want an actual number. All right, no problem. 8 pi is what? 8 times 3.14. And that is approximately 25.1. Yeah, 25.1. So 25.1, area of r is closest to 25. So number 25 is 25, and that's choice E.